let's just dive right in. Today, we're taking a look at a massive architectural shift happening right now in medical AI. We're touring something called the Clinical Cognition Operating System, or CCOS for short. Think of it as the literal blueprint for how generative AI is actually being transformed to work safely and effectively in medicine.
So here's the big question, right? What actually happens when you take a giant pile of AI medical prompts and engineer them into a functioning operating system? Well, you get something that goes way beyond your basic, everyday chat interface. We're talking about building a structured, safe, and truly pedagogical medical tool. One that's designed to scaffold human thought. That means it supports and actually builds up a clinician's reasoning, rather than just doing the thinking for them and spitting out an answer.
Okay, here's our roadmap for this explainer. We're going to start with the evolution from prompts to an OS, then walk through the 6 cognitive layers, dig into the safeguards of epistemic trust, check out the daily operations of pedagogy and module life cycles, and finally, get real about the system's current boundaries.
Let's kick things off with part 1, from prompts to operating system, laying that foundation.
You know, CCOS didn't just fall out of the sky. It evolved over 5 distinct generations. At first, back in Generation 1, it was literally just a prompt library, standalone, answer-focused prompts. Then, Generation 2 brought in modular reasoning using illness scripts, which are basically classic disease patterns. After that came Generation 3 with dependency-linked protocol networks. Generation 4 added a really cool metacognitive layer for detecting bias. And finally, Generation 5, that's where it absorbed all those earlier pieces to build the robust CCOS we have today. It didn't throw anything away. It stacked it all up into a framework built for continuous, longitudinal learning.
I absolutely love this concept because it totally nails the paradigm shift we're talking about here. Look, conventional prompt engineering basically just wants the machine to hand you the best possible answer. But CCOS, it is engineered to elevate the clinician's own judgment. It's not trying to replace the doctor. Instead of throwing out some falsely confident, potentially hallucinated answer, it gives you what's called explicit epistemic calibration. In plain English, that means it accurately maps out exactly what it knows, what it absolutely doesn't know, and gives you a range of defensible clinical pathways.
Moving right along to part 2, let's tour the facility and break down the 6 cognitive layers.
Okay, so imagine a patient case, entering the system kind of like raw material, going into a multi-story factory. The data flows linearly upward through these 6 connected layers. Down at layer 1, you've got basic clinical reasoning, like patient history and exam findings. From there, it gets passed up through workflow coordination, bias checking, trust calibration, decision architecture, all the way up to layer 6, which is this longitudinal learning archive. Basically, what you learn today feeds directly into your very next session.
Let's zoom in on layer 2 for a second, the workflow engine. The absolute key takeaway here is that sequence matters. It coordinates all the networks. And why is that a big deal? Because in medicine, running a safety check after you've already jumped to a diagnostic conclusion, that could literally cost a life. The system treats the exact order of operations as absolutely critical, not just a suggestion.
Then we go up to layer 3, metacognitive monitoring. You can think of this layer as the system's internal mirror. It's the part responsible for explicitly surfacing your blind spots during a diagnostic discovery journey. It's always in the background asking the hard questions like, hey, what assumptions are we making here? Or, are we falling for anchoring bias and just getting stuck on our very first guess? It practically forces the clinician to audit their own thought process in real time.
Next up is part 3. We're going to dive deep into the safeguards of epistemic trust, which is basically the system's security detail. This layer is really what separates CCOS from your run-of-the-mill AI prompts, so we need to understand how it ticks. There are exactly 3 named safeguards hardwired into this layer to keep things clinically safe. First up is hallucination calibration. You know how AI loves to sound hyperconfident? Well, if it hallucinates some incredibly specific number, like a 13.7% mortality rate, this safeguard catches it and bumps it down to a much safer, defensible term like moderate mortality. Second is prioritized claim verification. The system isn't wasting time fact-checking every single word. It focuses strictly on claims that could actually change a diagnosis or impact safety. And third is confidence calibration. It literally separates the AI's confidence levels across different domains, like diagnosis versus prognosis, instead of just giving you one big, misleading overall score. Now let me be crystal clear about something, because the source material hammers this home. The epistemic trust layer shapes the expression of uncertainty. It is not an automated external fact-checker. It's not out there Googling things on the internet unless a specific module tells it to.
Its entire job is just to make sure the AI is communicating its own internal uncertainty honestly and accurately to the human using it.
All right, on to part 4, pedagogy and module lifecycle. Let's look at the daily operations.
There is some seriously deep educational theory running under the hood here. The system uses 4 cross-cutting pedagogical frameworks, including stuff you might recognize like Fink's and Bloom's taxonomies. But the cool part is they aren't just tacked on at the end as an afterthought. They are woven directly into every single module. Whether you're dealing with polypharmacy or patient advocacy, these frameworks are constantly working to give the clinician durable, transferable insight. The goal is that you actually learn something you can use on the very next patient, instead of just grabbing a quick answer and forgetting it.
And all that pedagogy? It's delivered through a totally standardized process. Every single one of the 57-plus modules in the library runs on the exact same universal 3-phase life cycle. Initiation sets the stage and orients the AI. Execution runs the specific steps. But closure is where the real magic happens. Instead of just shutting down when a diagnosis is reached, the closure phase locks in the learning. It often includes a difficulty ratchet, which is basically like a video game leveling up the difficulty for your next session based on how you did. It turns a one-off case into a continuous learning curve.
To put this into perspective, let's look at Module 42, called the Clinical Premortem. This one is brilliant. It forces the learner to imagine that a terrible outcome, like a totally misdiagnosis, has already happened. Then, it makes them trace their steps backward to figure out what assumptions got them there. By making you argue backwards from a failure instead of forwards from a hunch, it completely exposes premature closure and anchoring bias.
Finally, Part 5, Boundaries and Future Reality. It's time for a reality check.
You know, the transparency of this framework is actually really refreshing. It doesn't pretend to be magic. It candidly lays out its own limitations. For one, it's a prompt architecture, not an autonomous, persistent software program. Right now, there's no machine-enforced grammar making sure a sequence of modules perfectly makes sense, and the handoffs between those modules are just free text. Plus, the library is a bit uneven. Some modules are super mature, others are still totally experimental. And hey, it's generative AI, so if you run the exact same prompt twice, you might get slight variability. It's a beautifully evolving framework, but it's not a perfectly finished product just yet.
Which leaves us with this final thought. Even with those boundaries, what CCS is doing is absolutely wild. If a structured prompt architecture can successfully scaffold critical medical thought, if it can audit human bias and actually calibrate trust, how is structured AI going to reshape the entire future of clinical reasoning? If we build AI to be a mirror that sharpens our own intellect, rather than just an oracle that spoon-feeds us answers, how permanently will that alter the clinicians of tomorrow? Thanks for hanging out with me for this explainer, and keep questioning.